Today we are going to discuss limit of piecewise defined function. So here we have limits of piecewise defined function. Okay. Now let us consider an example. Suppose f of x equal to 1 over x plus 2, where x is less than minus 2, and x square minus 5 when we have minus 2 less than x less than equal to 3, and under root x plus 13 when x is greater than 3. We have to find a limit when limit x goes to minus 2 f of x. Option B, and we have to find out limit x goes to 0 f of x. And third, we have to find a limit when x goes to 3 f of x. So you can see that we have to find out the limit x goes to minus 2. What does it mean? It means that it must, if you take a number here, suppose minus 2, so we have to consider in the right side of minus 2 and the left side of minus 2. Okay, so if you have to find out limit x goes to minus 2 f of x, then we need to find out limit x goes to negative minus 2 minus here f of x, and limit x goes to minus 2 plus f of x, right? So you can see that when x is less than minus 2, here when x is less than minus 2, you can see when x is less than minus 2, what we have this function. But when x is greater than minus 2, right, you can see it is greater than minus 2, then we have this function, right? So we have to consider, so basically when we have limit x goes to minus 2 minus f of x, then we have to consider limit x goes to minus 2 minus here 1 over x plus 2, 1 over x plus 2. And when we have limit x goes to minus x tends to minus 2 plus f of x, then we have to consider this function, right, x square minus 5. So here limit x goes to minus 2 plus f of x, which is x, f of x is here x square minus 5, right? So we'll write down here x square minus 5. Now, so I'll explain how to simplify this limit. So basically we have this, and here we have minus 2. So you can see that if you take any number, okay, if you take any number less than minus 2, how we can write down? So we have to take a number which is very close to minus 2 basically, right, in the left side of my negative 2. So what I'll do, I am taking an arbitrary small number h, and this is positive. Okay, so any number minus 2 minus h can be written, right, in the left side of negative 2. Similarly, if you would like to write down any number which is greater than minus 2, okay, so we can write down minus 2 plus h if h is arbitrary. So h can be here 0.1, h can be 0.0001. okay, basically it is a very small number. H is a very small number. Now so here what we can do, I would like to find out left hand side limit, and also I would like to discuss what does it mean by left side and right hand side. Suppose you have a number, any arbitrary number a, okay, so in the left side we can denote a minus, and a minus can be written as a minus h. Okay, in the right side of a can be written as a plus, and it is a plus h, right, where h is arbitrary small number and also positive. So h is arbitrary a small positive number. Now, so if you find any number, or if you find the limit which is less than a, means in the a minus, then we say it as a left hand side limit. Okay, left hand side limit. And if you would like to find out any limit of f of x in greater than a, okay, in the a plus, then we have a right side of right hand side, right hand side of limit. Okay, and we denote it as a LHL at x equal to a, okay, minus, and here RHL at x equal to a plus. Now what I am going to do, so here I am going to find out limit x goes to 2 minus f of x, and we know that limit x goes to 2 minus the f of x is 1 over x plus 2, right? F of x equal to 1 over x plus 2 when x is less than negative 2. Now here limit x goes to 2 minus, right? And here f of x, so 1 over x plus 2 here. Now what does it mean? X negative 2 here, everywhere I have to write on negative 2. No, negative 2 minus, so x goes to minus 2 minus h, we can write down h goes to 0. So then here I have to write down x equal to negative minus 2 minus h, where h is positive. Now so once I consider it, okay, so I have to change the limit. So here I can write down limit x, instead of x I have to write down h, okay. So h goes to 0. Here I have to make the function, here it is in f of x. Now we have to convert this function in the form of h. So we have to write down h in the terms of h. We have to write down this function in the terms of h. So what we can do, we have to replace x with h. So x equal to what? Here we have minus 2 minus h. So minus 2 minus h and plus 2, right? So here I'll put limit h tends to 0 and minus 2 minus h and plus 2, minus 2 minus 2 and plus 2 cancel. We have limit h goes to 0. Here we have negative 1 by h, right? So it give you minus infinity. Directly you can write down here, we can also write down minus 2 and plus 2, which is equal to 1 by 0, but this is the appropriate way to do it. Now so the limit we have, when limit x means when limit x goes to minus 2 minus f of x, then we have minus infinity, right? Now I would like to find out, so this is LHL, right? I can write down LHL here. I can write down LHL, left hand side limit at x equal to 2 minus 2 minus, right? So basically 2 minus indicating in the left side. If I write down 2 plus, it means that it is in the right side of. So here limit x goes to 2 plus f of x. We know that limit x goes to 2 plus the f of x should be x square minus 5. Okay, since f of x equal to x square minus 5 when we have minus 2 less than x less than equal to 3. Now so in this case we have to here so minus 2 plus x equal to minus 2 plus h I can write down, where h tends to 0. Now limit x goes to, so we have to replace here, so h tends to 0 now, and we have to replace x with h. So the here x is x square. Now we have to convert in the terms of h, right? So minus 2 plus h whole square minus 5. Now we can directly put the value, otherwise we can simplify and put it. So limit s tends to 0, and here we have minus 2 plus 0 whole square minus 5, and which is equal to 4 minus 5, which is equal to minus 1. So we can see that LHL at x equal to minus 2 is not equal to RHL at x equal to minus 2, right? So limit doesn't exist. Means when we have limit x goes to negative 2 f of x, it does not exist. We can write down does not exist. Now, so we have to find out the limit when x goes to 0, right? So you can see that limit x goes to 0 f of x. So in this case also we have to consider a function f of x equal to x square minus 5, since it lie between minus 2 less than x less than equal to 3, right? 0 is in this interval. That's why we have to consider this function. So limit x goes to 0 f of x x square minus 5, and we know that it is a polynomial, right? So directly we can put the value and we'll get minus 5. So because here we have it function is changing its behavior, right? So that is basically a suspicious point if you talk in this function. That's why we have checked at two different points. Means in the case of LHL and RHL, right? We have checked in when x goes to minus 2 minus and when x goes to minus 2 plus. Now, and also we have to find limit x goes to 3 f of x. So in this case we have the function, so we have to consider x when x is less than 3, right? So minus 2 less than x less than equal to 3. So we have function f of x equal to x square minus 5. But when x is greater than 3, then we have f of x equal to under root x plus 13, right? So we have to do in the same manner here also. So we have to find out LHL first. So LHL, left hand side limit at x equal to 3, right? So limit x goes to 3 minus f of x. So limit x goes to 3 minus means we have to consider here f of x equal to x square minus 5. Now limit, so what I can do, so x goes to 3 minus, it means that x equal to 3 minus h, where h tends to 0. So limit h tends to 0 x square minus 5. So I can write down 3 minus h whole square minus 5 and directly put the value, you will get 9 minus 5, which is equal to, since 3 minus 0, right? If you do it, it's going to be basically 3 minus 0 whole square minus 5. So we have 3 minus 0 as 3 square minus 5, which is equal to 9 minus 5. So it is 4. So we have to write down the answer is 4. Means when limit x goes to 3 minus f of x is 4. LHL at x equal to 3 is 4. Now we have to find out RHL. Okay, RHL at x equal to 3. So it means limit x goes to 3 plus f of x. So in this case we have limit x goes to 3 plus the f of x is going to be what? X plus 13. So x goes to, so here I have to write down x equal to 3 plus h, where h is s tends to 0, right? So here limit h tends to 0 and we can write down 3 plus h and plus 13. So put the value, we'll get limit h tends to 0. So here we have 3 plus 13, which is equal to 16, and it gives you 4. So LHL at x equal to 3 is going to be RHL at x equal to 3. Therefore limit x goes to 3 f of x exists. Both are equal and both exist also, so it is